Hello, year two. Okay, so we've got a new maths video for this week. We're looking at some new vocabulary that you might not have come across before, and I'm going to be showing you some examples of how that vocabulary is used and what it means. So let's have a look together. So starting off, this is the key vocabulary I'm going to go through. Now I'm going to take them all a bit of a time, step at a time, but you can see on the screen, I've kind of color coded them, and that's because those words kind of mean the same thing, just in a different way, all in orange, all in blue, and the ones in yellow, and then the ones that I've got in white at the bottom, they're something different, but they kind of linked with each other. So the first one that we're going to be looking at is we've got the words going from top, going down, and then the next line, we've got add, sum, and then on the other orange boxes, we've got addition and total. And then the blue boxes, we've got subtract, take away. Yellow box, we've got equal, and then the two white boxes, we've got inverse and fact family. These are all separate words, but they're linked a little bit in some ways. Let's have a look together. So the first one we just said, the first four we said was addition, sum, total, and add. So we can try those together. Addition, sum, total, add. Now, addition is all about making a number bigger by adding something to it. So for the first example, we can look at 3 plus 5. There's another one that you might have heard before, plus. You got 3 plus or add 5 is equal to 8. It's a form of addition. It's showing that that 3 is getting bigger by adding the 5 to it. Now, the next one says, what is the total of 5 add 4? What is the total, or what is the sum of 5 add 4? These are all words that can be interchanged. So total and sum is asking you to take all the numbers and add them together. What is the sum of 5 add 4? Or what is the total of 5 add 4? That's asking what's 5 add 4. It's just adding in that extra total or sum word that means the same thing. So that answer would be 9. The next one we've got is the word subtract and take away. Subtraction is all about making a number smaller by taking something away from it. So if I've got 7 and I've got someone's asking to subtract 5 from my total of 7, there it's going to be 2 because it's a form of subtraction. Sorry, I stumbled over my words there. Let me try that again. For the next one, we've got what is 5, and you are taking away 2. So you're taking 2 away, you're left with 3. It's just saying 5 take away 2, but it's adding in those different language so that you know what the question's asking you. We've then got equals or equals to, equal to. So equal to is when you're making both sides of the equal sign make the same number. So if you've got 7 add 3 on one side, you've got the equals in the middle and you've got 10 on the other side. That's saying that 7 add 3 is the same as 10. It equals 10 on both sides. You could also do it by having 2 different sums, 2 different addition questions or subtraction questions on either side of the equals. And it's your job to make sure that both of them equal the same amount. So if you've got 5 add 3 on one side, you've got 8 on that side. You've then got an equals. Rather than writing 8, you need to make 8 in another way using an addition or a subtraction. So for this one, we've got 5 add 3 on one side. We know that's 8. Equals the same as 4 add 4. That still makes 8, but it's saying that it's 8 on this side, it's 8 on this side. It is equal, it's equal to. Now we must remember that it doesn't always have to be a sum, something adds something equals the total. It can be something adds something equals the same as something adds something else. Or it might even be mixed, and we might have a minus on one side and a plus on the other side. It's a tricky concept, but with more practice, we'll get it really easy. Now, we've got 2 more, which I'm going to go through as we're going through the presentation. So we've got what is being represented here. Now, remember, represented is another word for being shown. What is being shown here? I'm hoping you're saying, I've got 7 counters. Another way, rather than counting, is you've got 3 counters that are not, it's filled in there. And we know that 3 matches with its number bond to 10 of 7. So I've got the total of 7 here. And I'm saying that I could change this 1 to being a different colour. And I could say that 7 is made up of 6 add 1. So that's my 6 red counters and my 1 yellow counter. Or I could say 7 is made up of 1 add 6. I haven't done anything different there. All I've done is I've switched the numbers round on one side of the equals. I haven't changed it with the other side, I've just switched them round. That's a really tricky year five word that we call commutative. Commutative. And commutative means you can swap those numbers round and it still gives you the same total. So this is saying that our blue number that I've underlined here, that's our whole. And our whole equals the same as 1 part in red, add 1 part in yellow. But the interesting thing about the calculation underneath is we've swapped the 1 and the 6 around, which is just the same as saying a whole, add part, and they've swapped over. It's commutative, they can swap, and that's okay. I could also swap it round by putting the equals at the end of my calculation by saying 6 add 1 equals 7, 1 part in red, add the part in yellow equals my whole. But I could also then swap them round and say my part in yellow add my part in red equals my whole. And that's a really important thing, that it's okay to swap them over if it's addition. If it's addition, when we're using plus, it's okay to swap them over on one side of the equals. This is what we call a fact family. And it's what we have as being, there are 3 numbers that we've got here, and together you can make a little fact family, little story. So we're saying that 7 is equal to 6 add 1. We're saying 7 is equal to 1 add 6. But 6 is equal to 6 is 1. 6 add 1 is equal to 7, and 1 add 6 is equal to 7. We've swapped them round. The first, we've swapped the numbers on the addition on one side of the equals round. Then we've moved the 7 to the other side, put the equals in the middle, and then swapped those numbers again. It just shows that there are different ways of making the same number, and we call that a fact family. Must remember that for this week. Now, I've done an even harder one here, and this is the fact family for the total number. So we're going to have a look at this one. So we've got, no, don't need to count them, Mr. Watkiss, because I can see that the 2 in the yellow are filling in that red counters 10 frame. So I know there must be 8 red counters, and then I know that I've got 2 and 4. So I've got 6 yellow counters. So I've got 8 add 6 equals, I think, count them all together, 1 full 10, 4 ones, 14. Now, before I change my equals to being at the front of my equation, my calculation, I can do something with my 2 numbers. I can make it into a fact family by swapping them over, doing, instead of part, add part, red part, add yellow part equals my whole. I can do yellow part, my yellow counters, add my red counters equals the whole. So let's do that next. So it should be 6 add 8, and I don't need to count them again because I've only swapped the numbers over. It's the same, it's commutative, which means the answer is still 14. Now the next one gets a bit trickier because my 14 is going to move. It's going to be at the beginning of my fact family now, and I've got 14 first, and it's equal to what? Well, I could go trying to work it out, but actually all I'm going to do is pick up my 8 and 6 and move them to the other side of the equals now. So I've now got 8 add 6. But hold on, I've got another 14 that I need to fill in. Well, because it's commutative, I just swap the 8 and 6 again, and now I've got 4 different calculations, all making the same number, showing the same working out. This is a fact family. Oh, showing you again my mistake. Here we go. So what's being represented here? We've got 7. Oh, and we've taken away one of those yellow counters. We've taken away one. And our answer now is we've got 6. So we've got 7, take away 1, we've got 6. Now this is referring to our subtraction. The other way we could look at it is 7, take away all of those 6 counters. We've now only got 1 left. Now this is where it gets a bit confusing, because Mr. Watkiss, you told me that we only swap the numbers on one side of the equals. Well, that was right, but only for addition. We're now looking at subtraction. We can't swap the numbers straight away on one side of the equals, because if we did that, it would say 1 take away 7 is 6. If I've got 1 and somebody says, can I have 7? Well, I've only got 1. So my answer is no, I can't. I can't just swap them round and it still be the right answer at the end. So I need to swap the number on one side of the equals, and I need to swap it with the one that's within the other side of the equals. But we need to make sure it makes sense. So we've got the whole is 7, one part is yellow for the first one, and we're taking that away. Our whole is 7 and we're taking away that 1 yellow counter. We're left with the 6 red counters, that's 6 part of our equation. We've then got a whole and we're taking away the 6 counters, and we've only been left with the 1 yellow. So it's, instead of swapping the whole this time, or the 2 parts over, we're still swapping those 2 parts, but instead of it being on one side of the equals, we're swapping them over the equals this time. Watch the animation. Let me move my face. Watch the animation. We're moving the red part and the yellow part on the other side of the equals, different to addition. So when we look at it the other way now, we could put our 6 as a part first, swapping it round from what's shown at the top here. We're just swapping it over and putting the equals at the beginning of our equation. 6 equals the whole 7, take away the part, which is the yellow counter. And we can still then swap it round, nice and easy. We're still going to leave our 1 first now. We've just swapped the 6 and the 1. The parts are the only ones that are swapping. Our 1 is first, and it says it's the same as 1 is equal to 7, our whole, take away the 6 parts. And you'll look at the animation now, you will see those parts just change over, because it's just showing you we're just changing those parts. We're not changing our whole number. The whole number stays the same the whole time, but we're just changing the equation so that it makes the same, but it's showing a different way of writing it down. Now, we've looked at addition, and this was the addition one. Now, it's a challenging one, but maybe you could have a think. You don't have to have a go if you're not confident. Just follow along if you're really not confident. And that's okay. We're going to go over this in class. But if you want to have a go, you can have a go now and pause the video and see whether you can fill in the other half of our addition fact family with our subtraction fact family to make it a full fact family that's including of addition and subtraction. Have a go now if you want. If you don't, follow along with me. We'll go through it together. Right, so let's have a look together. We've got take away as our first, which means we must start with our whole number. When we're doing take away, we must have the biggest number first. Otherwise, it's not going to make sense. If I've only got 1 pencil and somebody would like 5 of them, I can only give you 1. I can only give you 1. But if I have a selection of pens and pencils, and I've got 5, and somebody says, can I have 1? Well, yes, I can give you 1. But if somebody says, can I have 6? No, only got 5 at the minute. So it's all about making sure that biggest number is first. So our biggest number in this equation is 14. So we must make sure we're going to start with 14, do you reckon? Should we see? We've got 14, and we're taking away 8 Our 8 is our red counters. We're taking away 8 of those red counters, and it equals 6. There's 6 yellow counters left over. But we swap the 8 and the 6 around over the equals for our takeaway, and we've got 14. Take away the 6 yellow counters, and now we're only left with 8 red counters. But the next two, we've got 2 equals at the bottom, at the beginning of our equation. So we must now move the parts round each other so that we've still got our whole in the same place. 6 equals the same as 14 take away 8. It's the same equation. We did it just up here underneath our addition, but we've just swapped those two round. We've swapped our 2 parts round so that we can change it so that the whole is within the takeaway part, and we've got our part as being our other balanced section. So we've got 6 equals 14 take away 8, and 8 equals 14 take away 6. Now we've got part add part equals whole. We've got whole equals part add part. We've then got whole take away part equals part, and part equals whole take away part. We've just swapped the same numbers here, there, and everywhere, and we can just check our answers. Now, this, it's not popped up, but this takeaway here is what we call doing the inverse. Inverse. The inverse means doing the opposite. So if you've got addition, the inverse to addition is doing subtraction, because you are checking it by going back over your answer, but changing it to see whether it still makes sense when you swap those numbers around. That way you can do your best to make sure your answer is definitely right. Because if we rush through our work and write our answers down as quick as possible, sometimes we can end up making a mistake because we have not checked our answers. And that's where the word inverse comes in, because we check it by doing the opposite operation. If you're doing addition, you do subtraction. If you're doing subtraction, you do addition. And that's why fact families are so important, because you can always check your answer. Timmy's having a go now. We've got 6 red counters, 3 yellow counters. So he said 3 add 6 equals 9. 3 yellow counters add 6 red counters equals 9 as a total. He said that 3 add 9 equals 6. He said that 9 take away 3 equals 6. And he said that 6 take away 3 equals 9. Have a think. Which ones has Timmy got wrong? Because he's a bit silly and he's not checked his answers. Have a think. Well, the first one, he's got part add part equals whole. And the other one we're looking at is whole take away part equals part. Well, we can see that 6 add 3 equals the whole 9, and our whole, and that's absolutely right for the first one. So that's spot on. But the next one he's done 3, which is a part, add the whole equals a part. No, Timmy. The whole needs to stay on one side of the equals unless it's a takeaway. You silly sausage, you've made a mistake. So let's have a look at the next one. Our whole take away a part equals a part. Well, yeah, spot on. 9 take away 3 does equal 6. But does 6 take away 3? I've got 6 and I put 1, 2, 3 down. Am I left with 9? Timmy, you haven't checked your answer. You've just swapped the numbers wherever you want. It's really important to check that that answer makes sense. What we've got here is we've got 7 add 6 equals 13 as our total. 7 red, 6 yellow. Then we've swapped them round. 6 yellow counters add 7 red counters equals 13. We could do the same by saying 13 in the inverse, take away 6 yellow counters equals 7 red counters, and 13 take away 7 red counters equals 6 yellow counters. We can put this in a part whole model by saying that our whole is 13 and it's made up of 7 and 6. That's absolutely right. Hold on. One of the numbers has disappeared. Which number is the one that's disappeared? If we've got 7 and we've got 6, there must be one left over that we've not used. I know you're shouting at the screen. You're absolutely right. It's that 13. That is our whole number. So we must make sure that that goes in the 2 connecting part bubble. We've got our red. We can see the red ones disappear. Now, which one is the red number? Well, that is our 7. And we know that if we were to get rid of the yellow, that would be 6. Now, looking at a bar model, which we will be looking at, the whole is 13, which means we've got 2 parts. When we fill in a bar model, we don't just draw a line down the middle and say that 7 and 6 are equal to the same, because they're not. If I put 7 in a bar model, you can see that that bar is bigger than the bit that's left over. And that's because 6 is a smaller number than 7. 7 is more than 6, it's greater than, which means it takes up a bigger amount of the bar. Now we can see that the bar for 7 and the bar for 6 together makes the same distance, the same amount as our 13. And that's because 7 and 6 together make 13. And 13 is made up of 7 and 6. We can use this to help us with our addition fact family and subtraction fact families. These are all part of the 13 fact family, so that we can make 8 different calculations. Sums is only for addition. Sum is the word for addition. So 8 different calculations just for the numbers 6, 7, and 13. I know it's been a lot of information. Because it's a video, there's always the option to break it down. Go back to one part, have a go, come back to another part, have a go, and then come back to the third part and have another go. We can always go back to videos and revisit them. Thank you very much for coming along to this video. You've really tried hard. It's been a lot of new content, so well done. We'll be using this all of next week. So I really need you to be watching this video and to making sure you're paying attention. And in class, I want to hear you say, Mr. Watkiss, I know this. Or your other teachers, you need to shout at them and you need to say, I've seen this on the video. Well done, everyone. Great job. I'll see you in class. Goodbye now.